Let's try to remember the Schrodinger equation, which means we're trying to extract the kinetic energy and the potential energy from the wave function. And by performing this operation, we get the total energy of a particular n level. Well, if we're trying to determine the energy of a hydrogen atom, that's a spherical shape, so we're going to need to use spherical coordinates. We're going to see that the wave function depends on the n, which is the energy level, the L, which is the angular momentum, and the M, which is the magnetic moment. We're going to have to discover what those are. But we'll see that this wave function has a radius that depends on the N and the L. And we know that in spherical coordinates, there's two angles. So we have the first angle, which depends on the L and the magnetic moment, and then the last angle, which just depends on the magnetic moment. Each orbital has its own wave function. But let's just look at the 1s orbital, which is the simplest one we can find. This is when n equals 1, the angular momentum is 0, and the magnetic moment is 0. That wave function is going to look like this, 1 divided by the square root of pi a naught to the third e to the negative r over a naught. A naught is the Bohr radius, and of course this was normalized from the radius r is 0 to infinity to make sure that the electron is going to be found somewhere in the universe.